Hey everyone, I'm back with another practice session with you guys. This is again from this book, that is Principles of Electromagnetics by Matthew N.O.Sadiku, 4th edition. And the practice problem is 3.5. Okay, let's get set go. The question says, a square plate described by, this is the range that is given, minus 2 to 2 of x and minus 2 to 2 of y, z is equal to 0, carries a charge that is 12 y mod millicoulomb per meter square. Find the total charge on the plate and the electric field intensity at 0, 0, 10. Okay, first let me draw the square plate. This is my coordinates. This is my y, this is my z, this is my x, and since the square plate is basically on the xy plane, I'll draw it something like this on this xy plane, and it moves like from minus 2 to 2, and in the x range also minus 2 to 2, and we have to find the electric field intensity at a point 0, 0, 10, and it has also given that this surface has got a surface charge density of 12 y mod millicoulomb per meter square. Okay, let me write the range of x over here. That is this. It's given to us in our question. Yeah, this is clear. This is y, and between minus 2 to 2 and z is 0. This is the range, and this is where our square plate is located. Okay, first the question asks that we have to find the total charge on the plate. Well, total charge on the plate. Okay, and as we know that charge, when surface charge density is given, we can multiply it by the area. Yeah, and then we can get the charge. This is quite simple. I'm sure you all are understanding this. That this I'll multiply y mod, and what is the area? We know that this square plate is on the xy plane completely. So my area will be dx into dy. Okay, and I just need to integrate it in its ranges. That is, x is from minus 2 to 2, y is from minus 2 to 2. This is, it's like this. And you can see another thing, that this is y mod is given. Yeah, y mod is given. That means it's a even function. 12 y mod, it's a even function. See, I can write it something like this. Like this I'll write. This is 12. Let me put it outside. This is y mod dy, and then afterwards I'll integrate the dx part. And as you can see, this y mod, it's an even function. You guys know what is the even function? That is similar on either side of the x-axis. Yeah, this graph will give the same things. For negative values of y, we'll get the same thing as with the positive values. If I put minus 1, it will be 1. And if I put 1, then also this will be 1. So it's an even function. And why am I focusing on this part? Because now I can integrate it from 0 to 2 and multiply it with 2, because it's the same thing on both sides. Okay, I'm sure this is 12th standard maths. You all must be quite aware of it. Then this is what I'm going to do. 2 into y, I'll integrate from 0 to 2. Okay, because it's same on both sides. And y dy, this is dx. I can write over here y. It's correct, because from 0 to 2, y is anyways a positive value. Okay, then when we get this 2 outside, it became 24. And then x from this to this, y will be like y square by 2 from 0 to 2. Okay, like this. So what is it you're getting? This is 4 by 2, that is 2. 2 again I got. Multiply it here. And then dx from minus 2 to 2. Okay, then this is what? 48 into this one, I'll get x from minus 2 to 2. That is 4. So 48 into 4. So this will be 3 carries, 16, 3, 9, 192, and our units was in millicoulomb. So this will be millicoulomb. So the first answer is done, and we got we got 192 millicoulomb as it's the answer. But the next question says you have to take out the electric field intensity. Electric field intensity at this point, that is 0, 0, 10. All right. So how is it that we are going to take out that electric field intensity here at this point? 0, 0, 10. Okay. Electric field intensity, if you can see this, suppose I draw a random surface here. If I take a random surface here and then I try to take out the electric field, then I'll get something in this direction. Yeah, DE direction. Okay. So basically, if I choose any small surface, this small surface, I can say it is DS. Okay, DS I say. This is DS. Anywhere on this surface, I'll take a small surface. Then you'll observe that I'll be getting in this way. I'll be getting. So basically, the components on this sides will get cancelled, and only the components on Z axis will remain. So basically my electric field's direction will be a Z cap. I hope this is clear to you, that the net electric field will be in the Z direction. Okay, then let's calculate this electric field. Okay, electric field is equal to, what is the formula? This is charge divided by 4 pi epsilon naught r square AR cap, like this. And instead of AR cap, what can I write? I can write R in the direction, and this is 4 pi epsilon naught R cube. This is basically the mod. Okay. So what is this R? What is this direction of R? Let's go back to our diagram. Over here, from this surface to this point, I take it as R. Okay, clear? Let me draw from the center up to the surface one line. This is what? This is rho. Okay, this is minus a rho cap. This is minus a rho cap, and this one will be plus H A Z. Okay, this is the direction of R. See, let me write it out for you here. See, R is equal to we are going in this direction, opposite to a rho direction. So I can write minus rho a rho. You can see this is a triangle, right? So you have learnt in vector triangles, that if you add this, it will be equal to this R vector. Okay, so I can write like this, H A Z. I hope this what I've written is very clear to you. R is equal to minus rho a rho cap plus H A Z cap. Okay, let me put it in the equation. Let me write it over here again, otherwise for you. This is minus rho a rho cap plus H A Z cap, and this is R mod. R mod will be what? Rho square plus H square root over. Clear? Now let me substitute it in the equation. And also this rho S is 12y mod. This is also something I can write it in the equation. Okay. And our ds is dx dy. Okay, so rho s is 12y mod. Our ds is dx into dy. Our our r direction is minus our r vector is minus rho a rho cap plus H A Z cap divided by 4 pi epsilon naught. This is r cube, so it will be rho square plus H square whole to the power 3 by 2. And see this. the direction of electric field, as we saw already, will be only in the AZ cap direction. So I can very conveniently neglect this term. I hope this is clear. Why I neglected this? Because anyhow our net electric field will be in the Z direction. So this component I'll reduce it to 0. I'll not include it in my calculation. It's no use to unnecessarily lengthy the calculation. Okay, then 12 y mod, this is h, then this is dx dy whole divided by 4 pi epsilons naught rho square plus h square whole to the power 3 by 2, and all this is in AZ cap direction. Let me get a fresh page and then let's integrate this in its ranges. Okay. So what is it that I got? E is equal to I got 12 y mod into h dx dy divided by 4 pi epsilons naught rho square plus h square whole to the power 3 by 2. This is in AZ cap direction, and our integration range will be from -2 to 2. Y also will be from -2 to 2. Okay, let me take out all the constant terms outside, like 12h. Well, this h is that 10 that is given to us in our question, but it's a constant. So let me put it outside. Okay, and then what is remaining is this rho square plus h square whole to the power 3 by 2 dx dy integration. Y is from -2 to 2. X is also from -2 to 2. Okay, as okay, there's another thing. This is, we have written rho square. Okay, instead of rho square, you know rho square's value is, rho square is equal to x square plus y square. You know this? Yes, this is a cylindrical component. So I can, instead of writing rho square, I can write x square plus y square, because we are using Cartesian coordinates here. So let me use this x square plus y square in place of rho square in this equation. Okay, it's dx dy. So main thing in this question is integrating this. If you can integrate this, then it's well and good, because you can reach up to this, but then integrate it. Okay, as you can see over here, y, suppose we decide to integrate y first, like we had done earlier. You can see if I put any negative value in place of y, I will get the same thing as when I put a positive value. So basically it's a even function of y. Okay, it's an even function of y. So like earlier, I'll multiply it 2 times, I'll integrate it from 0 to 2. Okay, 0 to 2, and I'll multiply 2 over here. So this will become 2 into 12, 24, like this. Okay, so this is what I get. Okay, now I have to integrate it. How will I integrate it, guys? I will this is like y square plus a square thing. I can use y is equal to what is it I can do? How can I integrate it? Let me do one thing. Let me take x square plus y square plus h square is equal to t square. Okay, and now since I'm integrating only the y part, so others are constant for me here. So if I differentiate it, I'll get something like this. Okay, that means y dy is equal to t dt. So substituting it here, let me make it a little bit clear over here. 24h by 4 pi epsilons naught. This is x from -2 to 2, and this is what I'm integrating, y from 0 to 2, y by x square plus y square plus h square whole 3 by 2 dy. This is what I'm doing. Okay, this is what I'm integrating. All right. Okay, and now I'll substitute in place of x square plus y square plus h square, I'll substitute t square. So if I write t square over here, what will it become? T cube. Yeah, because t square whole to the power 3 by 2. It will become t cube. And on top it's written y dy. Again, this is y dy. I can use y dy instead of y mod dy because 0 to 2 y is anyways positive. So I'll write over here t dt. Okay, and integration limits, like you can see, y is 0, then t will be what? T will be root over of x square plus h square, and if y is 2, then t will be what? It will be x square plus 4 plus h square. Clear? Now let me put the integration range. X square plus h square to x square plus h square plus 4. Okay, clear? Then next, moving on, this is dx over here outside. Well, I think I need another pen. Okay, dx, integrate this x from minus 2 to 2. Ahead I can write 24h by 4 pi epsilons naught. Okay, then next, moving on, you can integrate this simple integration. This L cut, it will become t square dt by t square. So it will be minus 2 plus 1 by minus 2 plus 1, and limits, put the limits, that is x square, upper limit x square plus 4 plus h square. This is now dx, x is equal to minus 2 to 2, 24h by 4 pi epsilons naught. Okay, this, let me write it like this. Okay, fine. Then let me substitute it. This is what? T to the power minus 1 divided by minus 1. That is minus 1 by t. I got minus 1 by t. Minus 1 by t, and I have to put the limits. Okay. Yeah. Guys, solve with me so that you also understand. Or else listen to me and then afterwards in the end you can solve it by yourself so that you understand by yourself what is going on. Okay, then next is equal to 24h by 4 pi epsilons naught. Let me substitute these values. It's minus 1 by root over of x square plus h square plus 4 minus plus root over of x square plus h square. This is dx over here, and this is integration of x from minus 2 to 2. Okay, now we reached this stage. Now you can see x is also an even function because any negative value of x or a positive value of x will give the same thing. Like minus 1 you put, you'll get the same thing as plus 1. So it's even. So again I can integrate it from 0 to 2, multiply it with 2. Okay, let me get another sheet. Okay, let me write this thing again over here. E is equal to 24h divided by 4 pi epsilons naught. Then what is it? Integration x is equal to minus 2 to 2 minus 1 by root over of x square plus h square plus 4 plus 1 by root over of x square plus h square dx. Okay, dx. Okay, so let's do this even odd thing again. I mean even, this is even function, so I'll multiply this with 2. This is 4 pi epsilons naught. Then this I'll integrate from 0 to 2. Clear? Let me write this over here first. X square plus h square minus 1 by x square plus h square plus 4 dx. Okay, so this is basically our normal x square plus a square root overs integration. For those of you who don't know, let me do this. Let me do a integration of x square plus a square dx so that you can clearly see how to integrate it if in case you have forgotten its value. X is equal to A tan theta. Why tan theta I have taken? Because if I put over here A square tan square theta plus A square, then I'll get A square sec square theta. So that's why knowingly I have chosen A tan theta. Remember, for these cases you substitute A tan theta. Then dx is equal to A sec square theta d theta. Okay, clear? Let me write it over here. Instead of dx, I'll write A sec square theta d theta divided by x square. This is A square tan square theta plus A square. So down I got A sec theta. Okay, A sec theta. Clear? This is A sec square theta. So I got sec theta d theta's integration. And how do you solve this sec theta d theta integration? Well, remember class 12th maths, multiply sec theta plus tan theta up and down as well. Multiply it and then, hey, what you got? Sec square theta plus sec theta tan theta divided by sec theta plus tan theta d theta integration. So as you can see, the denominator if you differentiate, you will get the numerator. Basically, if down it's t or something, then the top one will be dt. Clear? Sec theta, differentiation is sec theta tan theta's differentiation is sec square theta. So I hope this is clear to you. So this I'll get ln t. So this is ln, this t is basically this sec theta plus tan theta. Okay, this should be very clear to you. So now ln, instead of sec theta, we had assumed that x by a is tan theta. So instead of tan theta, I can write x by a. And what is sec theta? Sec theta is root over of 1 plus tan square theta. That will be x by a whole square. So you got the value of this integration to be this. Okay, so similarly we'll use this thing in this integration to find our electric field intensity. So I'll write here 48H divided by 4 pi epsilon naught. Okay, the integration of 1 by root over of x square plus h square will be ln root over of 1 plus x by h whole square plus x by h. Clear? Minus, give a big bracket here, then minus ln, and over here you can see instead of a square, over here what's written? Instead of a square, it's written h square plus 4. Okay, so keep that in mind. Then 1 plus x by a. So our a, since a square is h square plus 4, so a will be root over of h square plus 4. This whole square plus x divided by h. So h is what? H square plus 4. Okay, this became, then this I have to integrate it from 0 to 2. Okay, I have to just substitute the values. And I know h is equal to 10 as it's given in the question. It's given in the question that h is equal to 10, 0, 0, 10. So h is 10 and see over here 0 if I put, then it will become ln1. This is also ln1, that's 0. So you can just put 2 over here in place of x and you'll get your answer. So it's basically 48 into 10 divided by 4 pi epsilon naught whole into ln root over of 1 plus 2 by 10. Clear, guys? Plus x by h, that is 2 by 10. Okay, root over, then next this became then minus ln root over of 1 plus, this is 10, so 10 square is 100, 100 plus 4, 104. So I'll get 2 by root over of 104 whole square plus 2 by root over of 104. Okay, now let me use the calculator and calculate it. Let me get my calculator. Well, this is 480 divided by 4 pi epsilons naught. Okay, all of you can also calculate with me. 480 divided by, actually it's not, let me multiply it by 9 into 10 to the power 9. 10 to the power 9, and there's something millicoulomb was given, I guess, somewhere. Yeah, 12 y mod, it was 12 millicoulomb, so into 10 to the power 3 as well I have to do. So this, you do it and then multiply it with ln, this whole term. Okay, so I have already calculated it, and so my answer that has come, it is, yeah, this is what I got. 16.46 millivolt per meter, and this is in AZ cap direction, and exactly that is your answer. Okay, so I hope this is clear to you and you practice this problem yourself and tell me whether you understood while solving it, and if you have any problems, then you can contact me. Thank you.